Hey, my name is Mike. I'm a developer from Philadelphia, and in this video, I'm going to be walking you through the Build Your Own Connect 4 AI machine learning project. In this project, we're going to be taking a look at the following key concepts, including minimax algorithms, strategy swapping, and writing evaluation functions. I'm really excited to get into this project, so let's head over to Code Academy and get started. Here on the left, we have all of our instructions and tasks. In the middle, we have our code, and we're going to be writing all of our Python code in here. And then over here on the right is our output terminal where we can visualize all the cool code that we're writing. Let's take a look at the project description. It says, build your own Connect 4 AI. Now that you've gotten a sense of how the minimax algorithm works, it's time to try to create an unstoppable Connect 4 AI. To create the smartest AI possible, you'll write your own evaluation function and challenge the AI that we've written to see if you can become the Code Academy Connect 4 champion. And I'm pretty confident that you can do that. So there's 13 tasks here that we need to complete. I'm going to walk you through each and every one of them, and we'll start by changing strategies. So we've imported the Connect 4 game engine along with the completed minimax function that we wrote during the lesson, including alpha beta pruning. And you can see all that code is over here, and then if you click on the little folder, the connect4.py file has all of the game engine stuff. So that's basically everything that we need to run our Connect 4 game. However, notice that we added a new parameter to the minimax function. The last parameter now represents the name of the evaluation function that you want to run. This essentially lets you swap out the strategy of your AI. So if you look over here, we have our minimax function. We're calling it with all of the arguments that we were calling it with before, but now we have this extra one here, which is a evaluation function. So essentially what we can do is we can create our own evaluation function or our custom evaluation function and put it in here. So that means that you could have one player using one evaluation function and another player using a different evaluation function, and then you can see how those functions stack up. So right now in 2AI game, player X is using the evaluation function Code Academy Evaluate Board, and that's what I had highlighted over here. And this is our secret evaluation function that we're going to try to beat. So for right now, let's finish the 2AI game function. The second player needs to know which evaluation function to use. Right now, we only have Code Academy Evaluate Board. Fill that in as the last parameter of the second minimax call and run your code to see the two eyes play each other with the same strategy. So essentially what we're going to do is just come down here and we're going to fill in the minimax function for player O. So if you look here, minimax, and then over here we need to add in the Code Academy Evaluate Board function. So let's do that, and then why don't we run the game and watch them play each other. So right now, both of these have a depth value of 4, which means they're going to be looking, to a depth of 4 for the different moves. So if we click save, then the board should pop up over here and we should see who won. So it looks like it was a tie, and that makes sense, right? I mean, I can keep clicking save here. They're both using the same minimax function, essentially. They're using the same evaluation function, so they should basically tie every single time. But let's modify these. So instead of 4 down here for O, why don't we make this a 3? So now X should be looking farther ahead than O should be, and so I would bet that X is going to win. And you can see here that X is probably going to win every single time now, just because X is always looking a step ahead. So that's going to do it for step number 1. And you can see we kind of played around with these. I'm going to put this back to 4 just so we're at an even playing field for both of these. And we'll head down to step number 2. It says, let's prove to ourselves we can easily change an AI strategy. Write a function called random eval that takes board as a parameter. So let's do that. And we'll do that down here below all of this stuff. Or actually, why don't we do it right here? So we'll create a function called random eval. And this is going to take in a board. And then down here, random eval isn't going to use any strategy. It's just going to return a random number between -100 and 100. We can get a random number using the random.randint function. So I'm just going to paste this in. And this is just going to give us a random number between one of these. So we'll just return this. And a good evaluation function should return a large positive number if it looks like an X is winning and a large negative number if O is winning. So this evaluation function is pretty much useless. So let's check off step number 2. That's done. We'll head down to step number 3, where we're going to replace the X player strategy with this new random one. So up here, we have the X player's strategy, which is right now Code Academy Evaluate Board, but now we're going to change it to random eval. And let's see who wins. So I'm suspecting, since this algorithm is pretty much complete crap, that O is going to win almost every game. So let's click save, and we'll see that. So as I keep clicking save, you'll see that O keeps on winning. That's because this algorithm is basically not an algorithm. It's just returning random numbers. Let's check off step number 3, and we'll head down to step number 4, where we're going to start making our own strategy. So it's now time to write your own strategy for your AI. We'll help you get started, but we want to see what you can come up with. And one of the cool things about this project is that we're going to kind of get to the end of the project, and there's going to be a lot more that can be done with this algorithm. So you guys could spend hours and hours building this thing and making it better. So to begin, we'll create a function named myEvaluateBoard that takes board as a parameter. So why don't we do that below this random eval function? You could actually get rid of this too if you want, but we'll just keep it for now. So this is going to be called myEvaluateBoard, and this will take in a board. That's going to be our function. So we'll check off number 4, and on to number 5. Let's first see if either player has won the game. So one good thing to do in our algorithm, right, is to check to see if anyone's won yet. And if someone has won yet, then our algorithm is done working. So we can use the hasWon function over here to check to see if a player has won. And it takes 2 parameters, a board and then an X or an O, and it'll give us a true or a false value depending on whether X or O won. So let's check this in an if statement. So I can say if hasWon, and in here, we're going to pass in board, and we'll pass in X first. So if X has won, and remember, this is going to return a true or a false value. So if X won the game, then we're going to return a float that is infinite. And then so we'll say else if has won, and we'll check to see if O won. Then down here, we're going to return float inf, but this time it's going to be negative. So basically positive infinity or negative infinity, depending on if X won or if O won. Now the reason I'm using an else if here instead of just an else is because we don't always want to return. We only want to return when someone has won. Otherwise we're going to come down here and we're going to end up doing a bunch more stuff. So let's check off step number 5. We'll head down to step number 6. It says, now we need to figure out how to evaluate a board if neither player has won. This is where things get a little trickier. If the game isn't over, a good strategy would be to have more streaks of 2 or streaks of 3 than your opponent. Having these streaks means that you come closer to getting a streak of 4 and winning the game. One of the trickiest parts of counting streaks is that they can happen in 8 different directions. So the whole idea is if you're trying to win a game of Connect 4, you can have streaks in multiple directions, right? So you could have, in the case over here of this board, you could have a streak going, vertically. You could have a streak going diagonally in all 4 directions or going side to side. So there's 8 possible directions that you could have streaks, which means there's 8 possible directions you have to look in to see if there are streaks. But for now, we're just going to keep our streaks to the right. So our algorithm is only going to be able to figure out if someone has a streak going from left to right. So like X here and then X here, that would be a streak. Or if we have O here and O here, that would be a streak. It's going to the right and it's going, to the side direction. And the point is that if X has more of those streaks, that means that X is probably winning. Now, obviously, this isn't like a bulletproof algorithm, but it's a good place to start. So inside our function, after the if statements, let's create 2 variables, one named X2 streak and then one named O2 streak. And we're going to start them at 0. So this is just going to be 0 and 0. And I'm doing all of this in one line just to kind of make it a little bit more compact. So why don't we check off step number 6? We'll head down to step number 7. Now we want to loop through every space on the board and see if there's the same symbol to the right. First, let's set up a loop that goes through every piece. So here's our loop, and we can just copy this in. And we want to make sure that we indent this second one. So this is going to loop through all of the columns and then all of the rows. And so down here, we'll be able to say board, column, row, and access an individual cell inside of the Connect 4 board. So as this loop runs, we'll look through each piece on the board, starting at the top of the leftmost column. The loop will go down that column until it reaches the bottom of the board and then jumps to the top of the second column. So here we have our if statement. It says if board at position column row and board at position column plus 1 in row are both X, then we've found a streak of 2 going to the right. So the whole idea is if this cell right here is an X, and then this cell over here is also an X, that means we have a streak. And so we can check that for all of these different cells, etc. So I could catch like these 2 X's, these 2 X's, these 2 O's, etc. I would be able to see all of those different streaks. So why don't we start implementing this if statement? I'm going to say if And we basically just want what's right here. So if I copy this, we can just paste this in, and it's literally the exact code that we want. So we're checking board column row and then board column plus 1 and row. And if this is the case, then we're going to increase x2 streak by 1. So I can say x2 streak plus equals 1. But here's the thing, we're not done with this yet. So up here, we're just checking board column row and board column plus 1 plus row, but we want to check to see if this is equal to an x, right? So I can say if these both are equal to x. So if this has an x value in it, and if this has an x value in it, then we'll increase x by 1. And then down here we can say else if, and we'll just copy this, and we're going to do the same thing for o's. So instead of an x, we'll put an o here, not a 0. And then here we'll say y2 streak plus equals 1. So real quick, one more time, what we're doing here is I'm saying if the cell has an x in it, and the cell right next to that, which I'm getting with this plus 1, also has an x to it, that means that we have a streak of 2 x's going in the right direction. So I can add 1 to x2 streak. Then we do the same thing for o's. So down here I'm checking the same thing, but for o's, and then I'm incrementing o2 streak. And actually I just realized I put a y here. This should be an o. I'm thinking xy, but in our case it's xo. So watch so you don't make that same mistake that I did. So one thing to note at the end here is that we don't want to check the final column because that column doesn't have a column to the right. So the outer for loop should actually look like this: for column in range length board minus 1. So we're going to modify this up here, and we're just going to say minus 1. And the reason that we're putting a minus 1 here is because if I'm over here on this cell and I try to execute this code, I can't go over to the right anymore. There's no more cells over here. So if I try to access a cell that's over here where my mouse is, it's not going to work, right? Because there's nothing over there. So that's why we need to put minus 1. So that way we stop over here. So this is the last one that we're starting at. So why don't we check off step number 7, and we'll head down to step number 8. It says, finally, after the x streaks and the o streaks, what should we do with them? Well, if x has more streaks, that means they're winning, and we should return a positive number. If o has more streaks, we should return a negative number. Returning x2 streak minus o2 streak will do exactly that. So I'm going to copy these, and we can just return those. So I'm going to say return x2 streak minus o2 streak, and that's going to do it. So essentially here, this is either going to be a positive or a negative number. Remember, if we have a negative number, that means that o is winning. If we have a positive number, that means that x is winning. So if x is more here, so let's say x is like 3 and o is a 1, that means we have a positive 2. But if o is 3 and x is 1, that means we have a negative 2. So that'll determine which side is winning. So that's how that works. We'll check off step number 8, and now we're going to test our evaluation function. So now that we've written this evaluation function, let's test it to make sure it's working correctly. To begin, comment out the function call of toAIGame at the bottom of your code. So here we're going to comment this out with a hash symbol. We don't want to play the full game until we know our evaluation function is working correctly. Next, create a new board named newBoard by calling the makeBoard function. So we're going to say newBoard is equal to makeBoard, and we're just going to call this function. So now we have a new board, and we can check off step number 9. We'll head down to step number 10, where we're going to make a few moves on the board. So you can do this using select space function. The following code would put an X in column 6. So why don't we do this? We'll put an X in column 6. So now if I click save, and actually why don't we print out the board? So I think you can do print board, and then we'll pass in the new board. So let's save this, and we'll be able to see our board. So over here we have our X, and I put that in index position 6. Why don't we drop another X in there? So now if I click save, you'll see we have our 2 X's stacked up. And we'll put another X in the 5 spot as well. So down here, I'll put one in 5. So now we have 2 X's in a row like that. And why don't we put another one in 5 as well, just so we have another where we have 2. So here we have 2 sets of 2 streaks, right? So here's a streak of 2 going to the right. Here's a streak of 2 going to the right. And then we'll add in some O's. So we'll come down here, and why don't we put an O here on 1, and then we'll put another O on 2. So now O is going to have 1, 2 streak. So that'll do it for step number 10. Let's check that off. And in step number 11, we're going to print the result of my evaluate board new board. So down here, we'll print that. So I'm just going to print this out. And let's see how we did. So what should we expect from this? Well, if you look over here, like I said, we have 2 of these X streaks. We only have 1 of the O streaks. So I'm assuming that it's going to say that X is winning. So we should get a positive number. So if I save, you'll notice that I get a positive 1. And that's because there's 1 more of these streaks for X than there are of O's. Now, if I changed these to O's, for example, if instead of X's here, I put O's here, you'll notice now that we're going to get a -1. And that's because we don't have any X streaks. So I got rid of both of those X streaks. And now we only have 1 O streak. So it's going to be -1. So I'll put these back to the way they were. So we're back at our +1. So it looks like this evaluation function is working. And here it says that you might also want to set up a board so X or O wins to make sure those conditions are working correctly. So you'll remember that we have these conditions up here, which checks to see if X or O won. So why don't we do that? We'll have one of these players win. So why don't we just drop 2 more into the 6th column here. So now it looks like X won. So we got infinity. But over here, if I change all of these to O's, so I'll make these O's, now we should get -infinity because O actually won. So it looks like our function is working correctly. Let's check off 11. We'll head into 12. It says, assuming your function is working correctly, let's plug this strategy into our toAI game function. Find the call of minimax for the X player and make the last parameter myEvaluateBoard. So I'm actually going to get rid of these 2 print statements here just so we can print out the actual results. We'll uncomment out toGameAI, and then over here in the minimax call for X, so here's the minimax call for X. Instead of random eval, that was our really bad evaluation function. Now we're going to use our custom one, myEvaluateBoard, and let's see how we do. Now this algorithm is pretty limited. We're only checking to see if there's any streaks going in the right direction, whereas the other algorithm that we had over here, the Codecademy one, is probably, well, it's definitely better. So if we save, I'm assuming that O is going to win, and you'll see here that O did win. So I could run this, a million times. O is probably going to beat us every time just because it's better. What we can do, though, is we could dumb O down a little bit. So over here, I'm going to say, instead of O being at 4, why don't we put it at 1? So the depth is going to be 1 for O. Now I think X is probably going to be able to win. You can see there, X1. If we bring this up to 2, maybe X could still win. Looks like O is winning. So instead of 4 here, we'll put this up to maybe 5. And you can see when we put this at 5, X was actually able to win. So, play around with these numbers and you can kind of see, what numbers allow our function to win, etc. But for now, let's check off step number 12 because we were able to see that our function actually worked. So now on to the last step where we can expand our evaluation function. So we have a good foundation for our function, but there's so much more we can do. And there's a bunch of ideas down here of things that you can add. So you could check for streaks in all 8 directions. Remember here, we only check for streaks in the right direction. You could weigh the streaks of 3 higher than streaks of 2. You could only count streaks if your opponent hasn't blocked the possibility of a connect 4. You could only count streaks if there's enough board space to make a connect 4, etc. So testing the function on test boards is critically important before plugging it into toAI game function. So make sure you know that your function is working how you expect it to work before challenging your AI. And then if you look in the hint down here, they have the code for their evaluation function. And I'll let you guys go and read through all of this and kind of study the code and see what they're doing. But really, I think the cool thing about this project is it is so open-ended. So we have a nice little foundation here that you guys can go off of. And you saw how we could do something like checking 2 streaks and plugging that back into our algorithm. So I'm going to leave this for you guys to do on your own. Make sure that you take your time with it. Obviously, there's a lot of ideas here that you can try and implement, but that's going to do it for me in this project. Real quick before we do wrap up though, I just want to go over what we did. So up here, we wrote our evaluate board function. And the first thing this did is it just checked to see if either X or O had won by calling this has won function. Assuming that one of them had won, we returned either a -infinity or a +infinity. If neither had won though, we came down here and we checked to see which had more streaks going in the right direction. So which had more 2 in a rows going in the right direction. And we used that to kind of determine which player was doing better. We returned to the difference, and that was what allowed us to figure out who would win. Then we took all that and we plugged it back into our minimax algorithm function. and we were able to play around with the different depth values, and depending on the depth values and obviously depending on how good this function is, X or O won in the end. So that's going to do it for me. I just want to say thank you so much for watching. From all of us here at Code Academy, I've been Mike, and happy coding.